Hello, so today we are going to do this problem called add one row to tree. This is part of Leetcode daily challenge. So the problem says we have a root of a binary tree and we get two integers, we get value and we get depth. And what we want to do is add a row of nodes with value this at the given depth, right? So what that means basically is that, I'll say here we have depth equal to 2 and the value is 1. What we want to do is for depth 2, we want to add 1. So you can think of like the root has depth 1, right? And so the depth 2 is this here. And what we want is to replace it sort of with depth, with values 1. So you can see here, instead of having depth 2, instead of having 2 and 6, we put 1. And what do we do with these subtrees? Well, the left one, we add it as a left of the leftmost one. And the right one, we add it as a right child of the right one. Okay? Here. Where did these rows come from? It's from these, like, this description here. So if we take a look at this, first thing it says that with depth, for every non-null tree node, at the depth minus 1, so here at depth 1, which is 2 minus 1, what we want is we create two nodes with value val that we get here, but we make the left subtree of the nodes at depth minus 1. So this is like a generalized description. So the left of the nodes at depth minus 1 would have a value of 1, and the right side would have that value of 1 as well. So when we find depth minus 1, that's where we attach the values that we want for the level depth. And so whatever current node we are looking at in depth minus 1, we want to make its left subtree the previous left subtree. So that means we want to make the left subtree of this one the previous left subtree, which is this one. And similar thing for the right subtree, right? So we want the original right subtree to be the right subtree of the new right subtree root. So of the new right one, which is this one. And one caveat though is if depth equal to 1, which means basically we are dealing with the root node, then we don't have a depth minus 1, right? We don't have a depth equal to 0. But what we want to happen is that create a tree node with value, so that would be the new root. And the original tree root would be the left subtree, right? So let's say here, for example, this was depth 1, for example. So what we want to do then is make 1 the new root, and then make the existing tree its left subtree. So it's left subtree like this, and it will have no right subtree. So that's the problem. Yeah, so if we take a look at more examples, depth equal to 3 here, we take a look at depth 2, and then we attach them as children of it, and we take the previous left the previous left side, we put it on the left, the previous right side, and we put it on the right. Okay, so that's the problem pretty much. Now, initially looking at this, it should be possible to solve it with DFS and also BFS, right? So yeah, with DFS, it should be pretty easy. We should just keep track of the depth value, and when we reach depth minus 1, just do exactly what the problem tells us to do. So let's see how we do that. Okay, so let's see how we can solve this here. So what we want is we want to take the depth minus 1 and assign the left of it to be a node with a value, and with the left being the previous left, and to the right of it a node with value, and to the right of it to the right of that the original right subtree, right? So we can do DFS and just keep track of the current depth of each level, and once we reach the depth minus 1, assign. What do we need to assign? Well, we need for the node that left, so this would be a node at depth minus 1. So what we want to assign is a new node with value val, right? And the left side needs to be the original left, right? So we want the left side to be the original left, but we want to keep we want the right side to be nothing. So here it's none. And a similar thing for the right, we want, this is again a depth -1, so we want the right to be tree node with value val. And we want the right node to be node.right. But we want the left side to be stay none. So that's why we don't assign anything here. And when do we want to do this? Only if the current depth is equal to depth -1, right? Because we want the values at depth, so which are node.left and node.right, to have a value of val, right? So this would be like the processing step in our DFS, and so that's what I have here. So our DFS will have a node, and will have the current depth, and once the current depth is equal to depth -1, we will do the assignment. But we also want to return node, right? Because we don't want to keep going, because as we go, the current depth increases, and this will never happen again. So we are done with this path, right? So that's why we return node here. But otherwise, if it's smaller still than depth -1, we want to continue recursing so that we can get to it. And so we traverse node.left and node.right, and each time we increase the width, the depth by 1, right? And then we return the node at the end. Now there is one other case that we didn't handle, which is if the depth is equal to 1 here, which means we want to replace the root, then what the problem asks us to do, so there is no depth -1 because depth -1 is 0 and the root starts at 1. And so what it tells us to do here is to make the root be a node with a value of val, and to make the original subtree a left subtree. And so we can do a special case for the root, and I have it here when depth equal to 1. So how do we detect it? It's when the current depth is equal to 1 and the desired depth equal to 1. That means we want to replace the root. And we want to do exactly what the problem tells us to do here, which is have the root be a new node with a val and have its left side be the original root. So that's what we have here. And no right child, right? And so we can just return that so it acts as the root. And then when we are initially calling our DFS function, we just pass a root for the node and we pass the current depth to be 1. Yeah, because the root is depth 1. Yeah, so that's pretty much it for the DFS solution. And note each time we are returning node, and what this would mean is that it will bubble up at the end, and when we call with root and depth 1, we'll get back the root, so we can just return that, right? So let's code this up and make sure it passes test cases. Okay, so what do we need first? Well, we need DFS on node and the current depth, right? And we want to return a DFS. The initial call we want to do is a DFS on root, and the initial depth is 1. And we, of course, want to do our base case where if node is null, we want to return just that node, right? Back to the parent. And first, we want to handle the case where the depth is 1. So we want to replace the root. And the current depth is 1, which is the first step. Then we want to make the original tree to be the left side, and then we want to make the root have a value val, right? That we get here. Now the other cases, so if the current depth is equal to depth -1, then we want to make the left be the original left, so no right, that's what the problem says. And for the right, we want to make the right be the original right, but no left subtree, and we want to return that node because we are done at this point. But otherwise, we want to recurse, right, on the rest of the tree. So the left side we recurse, but we increase the depth, and right side recurse, increase the depth, right? And that's pretty much it here. So let's run this. Let's submit. And that passes test cases. Now, one thing that is not ideal here is that we are doing 2 checks here. Ideally, we do this step with this one. So how do we do that? Well, we can just make the root not the root. We can make it a child, right? So let's just have a dummy node with value just anything. So let's just pick none. And since the problem says we want to replace the left when depth equal to 1, we want to replace the original tree, make it the left tree, right? So what we do here is let's just do that, make it the root here. So what we'll get back in DFS here, since we passed the dummy, is the dummy node, but we want the root of the tree, so let's just make it left here. Okay? And what will happen here is that when we are at depth, so since we have a dummy node, so that's level 0, because root is level 1, it's left child, so we need to pass 0 here. So now, when the desired depth is equal to 1, the current depth will be 0, right? So here we will have the dummy node as node, and so we'll assign to node.left a new root with value 1, or whatever value is, and we will make the left side be the original left side, which is the root of the original tree, and that's exactly what we want. And the right side would be of value 1 as well, and it will have a right node of none, but we don't care about this side here because we are returning only the left. And so that would be exactly what this function does. And so we can get rid of this. And yeah, that's pretty much the only modification we need to handle both of them in the same if case here. So let's submit. Okay, so that passes test cases. Yeah, and that's, I think, pretty much it for this solution. Please like and subscribe, and see you on the next one. Bye.